Thank you.
Thank you very much. Welcome back here on the center stage. Short information for you, all the things that Robert said in his keynote about Neos 9 or Karsten are now online on Neos.io on a blog post, so you can read all the details. But now we have on stage Leonard Follner from Sandstorm. Leonard, if you wondered who works on the lighting and the video and everything over there on the front of house, it's Leonard. Please come on stage. He's a full stack developer at Sandstorm, and he works on this project that he's going to talk about very soon. But you're not from Dresden, you're from Weimar.
Yes.
That is very important.
One of the two Thuringian expats of Sandstorm.
That's the other one.
and you told me that, unfortunately, this project is so exhausting and you have so much to do that you didn't make it to get a new haircut.
Well, it's not exactly stressful, but there's quite a lot of things to do, as you'll see soon.
Perfect.
Also, in an earlier conversation, he told me that while this project was not exactly stressful, this whole music and light business really was.
Yeah.
So just for your consideration, all of the work that the Sandstorm team is doing, so we aren't too quiet and too dark.
Thank you. Oh.
One more quick thing before I leave you guys. Don't forget to send in your questions, because we will want to ask them when he's done with his talk. So if you have any questions, write them down, send them in. Thank you.
Sweet, thanks. But my keynote is doing fun things. I don't know whether it's the clicker or it continues on its own. I'm going to start, and someone has to fix this in the background. Anyways, I'm going to take you on a ride through our project. 360FF is the company behind that we are working this for. It's called Ökokisten in German. I'd call it ecobox in English. We'll see. You see, like, back there, I had to do everything live. This is wholly pre-recorded, right? So my keynote does its own thing, and I'm just talking to it, basically. But the ecobox project, Ökokisten, it's a modern shop system for organic farmers. They sell their goods through it, but not just their goods. They also sell like cosmetic products or things they buy from other farmers in the vicinity. And yeah, it's a white label product. So we run this shop about 50 times. And it's not just like, don't imagine your Tante Emma Laden in German. This is not a small organic farm. These are big modern online shops. So you'll see soon what that means. So, but it is a niche solution, right? It is all about these organic farmers selling these eco boxes, as you can see here. And this is the central part to all of it. So let's go into it. What are these eco boxes? They are pre-packaged boxes that you receive perhaps or most likely on a weekly basis, for example. So as you can see, I've got the delivery options down there, and I can deliver these on a weekly basis, on a bi-weekly basis, monthly, whatever suits me. And these are pre-packaged by the farmers. So if they find beetroot on the fields, or if someone sells carrots and has a lot of them right now, they get to choose, oh, this week we're going to deliver beetroot. So it's really a sustainable idea behind that, to sell what is on the field right now and not let customers pick it. So let's check what box I'm going to get on Monday. So you see, I've got the Gemüsekiste vegetable box on order, and I'm going to get some aubergines, carrots, bell peppers, some mushrooms. This is what they want to sell to me this week. But the interesting thing is, see, this is an order until Monday the 3rd, so next Monday. And below it says, I can still make changes until Monday noon. So it's not really, like a basket is not automatically an order. I can change that up until Monday. So let's do that. I hate aubergines, get rid of those. This basket offers a lot of functionality. So let's look at one of these items. You've got swapping articles, because this is a recommendation, and if they offer me beetroot and I don't like beetroot or aubergines or whatever, I can swap it and try to like find something better, and they will deliver it for me. Or I'm thinking, like, what can I do with Riesenchampignons, like giant mushrooms? So I can find recipe ideas down there. And this is another core principle. They try to leverage synergies between all these 50 instances, because those recipes are shared all across those 50 instances. Just to compare it, like the Amazon basket is kindergarten to this, because the Amazon basket is just like put items in there, submit it, done. Here, we've got a delivery date. Until that delivery date, as I said, we can change it. We've got recurring products. We've got products that are tied to local availability. We've got holidays that move those delivery dates. And we've got a really high dynamic within the product range because of the local, like whatever their local farmers and producers have in stock. Perhaps they catch some fish, and this fish is just, like they have just 50 fish, so that's what we have. Amazon, can you imagine like, just having a couple of pieces of a high-selling product? No. So complex basket logic. And so we've got, across all 50 instances, I'd say about 20,000 orders a week, and I'll show you later why that is going to be a problem, that order volume. And besides those vegetables, you can add just about anything in there. Depends on the instance, but this instance that we mainly, like, that we all started with, they also have like cheese, baked goods, cosmetic products, and you can just add any individual vegetable or fruit that you like in there. What does that mean for our architecture? We started out with, there we go. We started out with one upstream service. It's called Ökokisten Online, and there, this manages all the orders, this manages the product catalog, the product availability, all of that we get from Ökokisten Online. We used to, in the beginning, make direct requests to that upstream service. So the client loads the web page and the JavaScript makes requests to that upstream service. That came with some challenges because like, we did not have under control the API of that upstream service and so on. So we introduced a middleware server that runs on Neos, and along with that, an API server. That brought a lot of advantages for us. So we had control over stability. We could store transient states. So like the whole basket logic is managed by that middleware server and is not going into that Ökokisten Online server. But we keep it and just tell the Ökokisten Online, the upstream service, this is going to be the product. This comes with a lot of observability, right? If we were to just send the basket to the upstream service, we were not to see what the client put into the basket, what the order was going to be, and why bell peppers ended in that basket in the end. Where does that come from, or what's the matter with a recurring product? So all of that we can see on that middleware service. And the transient state also allows us to keep a lot of it allows us for some deep integration. So we can build those recipes just with the products of that instance, and not with products that are not available right now, for example. That would be significantly more complicated if the product catalog was just on the upstream service, but we keep it also on the middleware server. Yeah, those are the points I just went over. Anyway, did I mention this is a white label? So like this page could also look like this. It's like just different colors, different fonts, different icons. And the interesting thing about this, but we did another NeosCon talk, I think, about it. the fonts, the icons, everything can be customized right in Neos. So this is not pre-rendered by us, but chosen by the instance themselves. Go back and check a talk, I think 5 years ago? I don't know how long ago we did that. Anyway, what does white label mean for the architecture? Back to that. This would actually look more like this, scale to 50 servers, 50 orders. And as I said, this is running about 20,000 orders. Every shop has about 5,000 products, depends on the scale, some more, some less. And this is all running on just one server. So this is a lot of instances running on one single piece of hardware. Guess what? Here comes challenges. So Christmas came around. We did a rewrite end of last year, and everyone wanted to be live with the rewrite, all of these 50 shops by Christmas, because Christmas is a lot of business for all of these instances. Imagine everyone like ordering their duck or whatever you eat for Christmas dinner. Depends, I guess, where you come from. All of those go through these shops. So Christmas caused a huge spike in our order nature, in our orders. And another thing we have, let's take a look. This is our diagram of successful orders. And you can see this is across a week, and we certainly have a spike on Saturdays and Sundays, because everyone sits down at home, plans their basket for the upcoming week, and then submits their order, right? It's just a natural thing to do on a Saturday or a Sunday and plan your next week and your next meals. So Sundays, we have a huge spike in traffic. And the same with holidays, Christmas. So let's take a look at a Sunday evening before Christmas. This is our CPU usage. It goes all the way up to 800%. All of our cores were done. You notice, you reloaded, and then your basket was there. So it took some time. This is net data, by the way. It's a great tool. Shout out to punkt.de for just pre-installing this on our server. You just drop this tool onto your server, and you get metrics of CPU usage, memory usage, all the applications running. Basically no configuration, but fun. Check it out. So we had a problem, right? Before Christmas, high CPU usage. How could we decrease this server load? This is where I'm going to dive into the main topic of my talk. How did we figure out what our server was doing and where we could go into optimizations? One of the main principles that we use throughout this entire project is our logging concept. We don't understand logging just as a debugging tool. So we don't have just var dumps scattered around and you don't really know where they come from. We have a logging concept because we try to understand logging as yet another tool for profiling. What does that mean? So first we start out, you can see just some random log from our server, and all logs, ignore those pesky exceptions, but all the logs themselves have the same format. Let me show you in the code what that looks like. For one upstream request to our upstream server from the middleware server, we always log the same fields. So we've got our event type, success, failure. We've got the host, the instance that this request originated from. We've got the API action that triggered that upstream request, or the context. We've got the URL that the client called, and we've got a request body, and optionally more fields for more context. But these fields are always there. And it's the same for the request failure, so same format. Those log lines go through Redis for decoupling, nuts.io for shipping, and then they end up in ClickHouse. I don't know how familiar everyone is with ClickHouse as a database. So ClickHouse is a mass storage database. It does compression really well, and it has a column-focused storage system. So if you ever need to go through like big amounts of log lines, this is probably your go-to for storing and querying. What do we do with all of these logs in ClickHouse? We build a dedicated Grafana dashboard. This is probably no big surprise, but all of this data is coming from our logs. So up here, we've got like request response times, because those are also part of the log lines. How fast, basically, left is how fast are we responding, right is how fast the upstream, anything concerned to upstream, the upstream service. So how fast are we responding? How long does it take for us to make one upstream request and get a response? Again, this is all like local, not local, but our middleware server, and this is all anything upstream, so successful requests upstream by API endpoint, drill down of error message that we get, stuff like that. So this already helps us, because we have this logging concept. For any of these API and upstream API endpoints, we get one log line, and this allows us to see, like, on a granular level, what is happening. We have this whole overview of the system, what is happening, so you could spot anomalies here, for example, or here you can see this spike all of a sudden. Don't know where that comes from, but also you can do a drill down and just filter all of that data. You can see that, but Grafana has an excellent filtering option, or go directly into ClickHouse and filter that down to a single customer. What did that customer do on a particular day? And you can also see like upstream requests, what happened, what did they send to the upstream service. Okay, this gives us an idea what the customers are doing, but this does not give us an idea of what our system is doing. So we got another tool for that. That is called Xcymer. Quick show of hands, who has heard of Xcymer? Wonderful. Let me introduce you to a production production profiling gem. This is like a hidden tool. Sentry uses this for internal monitoring. This is how we heard of it. It's a sampling profiler. So every interval, it checks what the server is doing, where are we in the code base right now. And it has very, very little overhead. So you can just turn it on in production, gather your data, and stop. I'll show you how this works. And, wait, yeah. Does anyone know the PHP auto prepend file feature? We're getting into, yeah, 2 shows of hands, excellent, 3. We're getting into some niche PHP configuration here. So in the PHP ini, we configure our Xcymer extension, but we also have this auto prepend file function. This allows us, before the main PHP file is parsed, any file that we configure there is loaded first, before every request, before every main file. So we go into that auto prepend file and clicker, so there we go. We have this start Xcymer function that configures Xcymer. Down here, we've got this commented lines starting start Xcymer that calls this function. So I want to see what my server is doing right now in production. I'm just going into that auto prepend file, uncomment that line, and my profiling starts. No restart required, no interruptions to production, nothing. It just starts its tracing. Definitely turn that off, because otherwise you'll end up with gigabytes of traces within minutes. We had that, but it really accumulates fast. So what do these log files look like? They are rather simple. Okay, never mind. This is probably too small for anyone to read, but it basically says you have this function call, find file with extension, and it was running for 1 tick. So 1 sampling tick here you've got one variable frontend get. It ran for 2 ticks. Ticks, we configured those. Let's go back one slide. We configured our ticks to run once a millisecond. So this function was on for 1 millisecond. This is terrible to read, right? So we built a profiling tool that got this sampling data, runs conversion and compression, again with ClickHouse, but this time ClickHouse local on it. And then we end up with a very compressed Pocket file. That's what they are called. It's basically a database, a ClickHouse database. And then we can run analysis, conversions, aggregations on this again. It says ClickHouse local here, but basically this is SQL querying. This is the nice thing about ClickHouse. You get all the benefits of ClickHouse and can still use regular SQL, mostly. And then we can take that, whatever comes out of that, and go into whatever visualization tool we want to have. So we use SpeedScope for all of that. Oh, yeah, that's an important point, actually. Let me go through. Because the whole benefit of all of that is, whatever. All the data on the server, we have just the data collection. We do not have the analysis or aggregation or anything. So this is what helps us to have a really, really little overhead. Because on the server, we just do the sampling, and anything after that is local. So the error right here is just downloading, basically. Download your data. So let's go back to the visualization to help anyone make understand of that. This is a flame graph, so we've got all of the function calls here, and you can see, for example, this is the middleware chain that Neos goes through, and on the right here, we go into whatever middleware is doing. Spoiler to the next part of the presentation. But this goes all the way down to the very, very last function call, and you could, for example, go into any of these functions, and the more space they take up, the more ticks they were present in your tracing. So this is, those would be the functions where you could think, is it okay if my server spends that much time rendering in Fusion, whatever that is? So what did we discover in all of that with net data, with this? One thing we noticed in net data was we had a rather high CPU usage of our database. So you can see this green yellowish part. This is MySQL, and it took up until like 5 cores of CPU. Is that appropriate? I don't think so. So another sweet little logging tool. You can log your slow queries in MySQL. This is hopefully familiar to more people. Just log into your database and go log queries not using indices on. This will generate a huge log file. Again, turn this off as soon as possible, because per query, you will get one log saying this, if it doesn't use an index, this query does not use an index. And this will, if you have a rather large system, there's going to be a lot of SQL queries. So turn that off, but go into that file that you configured elsewhere in your MySQL configuration, and then you see all the queries not using indices. So what does that look like if we turn them on? Ta-da! Like turning these on decreased our CPU usage of MySQL significantly from 5 cores to down to 1.5 cores, which I think is much more appropriate. That was the first optimization we took in December, I would say. Yeah, one of the first optimizations we took. So go into your database queries, turn on those indices. And another one we discovered, we spent a lot of time within the entity manager of Neos/Doctrine. So Doctrine booting up that entity manager, entity manager, and doing field mapping for queries from your database. In our case, that took a lot. So our goal is to reduce the ORM usage bit by bit and do everything with native queries. But that might be a preference of like performance versus a development experience. But that's what we did for our project. Database queries were not the biggest performance optimization we could do, though. This was rendering. In the profiling results, think of the speed scope and the flame graph. We discovered that we spent a lot of time in the Fusion runtime booting. Where does that come from? We're like, huh? Okay, and before anyone says, oh, Neos has good caching, so just utilize that caching. May I remind you, our basket is rather complex, and so are all the product pages. Because this doesn't really apply here. We've got, the rendering depends on the tool the user has chosen. The user itself, because not all users get the same product, which delivery date was chosen, is the product available at that date? So a lot of dependent variables for the caching. But okay, what does that mean for our product page, for example? This is a listing page, so it's the same for vegetables or fruits. And we started out rendering all of that in Fusion. As I said, we spent a lot of time in the Fusion runtime booting, and that was probably because we have got a lot of markup in here. Like, sorry, we needed a higher ceiling so the beamer, the projector window could go below, but down here, imagine like thousands of more products. This is a lot of markup. Fusion takes forever to render that. And each of these tags meant booting Fusion once. So our rendering stack at that point looked, client does a request to Neos, Neos boots up Fusion. So how could we improve that? Well, get rid of Fusion, at least in the markup-heavy parts. We introduced PHP rendering. So at some point from Fusion, we transition into PHP rendering, and PHP renders at least the markup-heavy parts. So remember our list down here. This is now rendered by PHP. We still want to keep Fusion just in case for the page layout, because that is shared across a lot of all the pages basically. But the markup-heavy part is now rendered by PHP. Let's go back to our rendering stack. We've got this for all of these Neos pages. This is totally fine, right? We get a request, we go into Neos, boot up Fusion, and then go into our PHP rendering, which at least increases the performance for this markup-heavy part. The problem, though, is Neos itself already takes a lot of time for rendering, right? Or for booting, because on all of these shop pages, we basically have no Neos content. So it's just shop content. We can get that from our local database. In theory, great. We had to do the next step, though. We did the same rendering stack with a separate Fusion runtime. So we're not starting Fusion with Neos in the background, but we started another minimal Fusion runtime. This does not know about a lot of things that Neos adds to Fusion. So we just have minimal Fusion runtime and render our shop pages in there through the same Fusion PHP stack. How do we know which track we should choose for rendering? This is why I keep talking about a middleware rendering server. In the middleware rendering chain of Neos, we introduced a middleware deciding, oh, this is a shop page. Don't even think about booting Neos. Just go right into our minimal Fusion runtime. So this is great because now we don't boot Neos for most of our pages because a lot of your traffic just happens on the product pages. But instead, just go right into the rendering. And this allows us to render this product page, besides all the complexity and rendering it every single time. This allows us to render this in under 200 milliseconds, I think, which I think is OK compared to the time we spoke about before that. But there is a problem. This page is not entirely free of Neos. Can anyone spot it? Like, up here, we've got a menu, and that menu contains Neos pages. Like, this is a mix of, you can see here, those are shop pages, but up here we've got those about us, the blog, the recipes, those come out of Neos. How do we get at least these links there? Well, we decided, let's just pre-render them. Every time anyone publishes anything in Neos, hits the publish button on the top right corner, you all know the orange glow. In the background, we hooked onto that publish event and rendered the menu, booting up Neos in the CI, not CI, but in the background, render the menu to a static file. So whenever we display a shop page, which we do not load Neos for, this is not rendered by Neos. This is static HTML. This allows us to separate Neos and the shop pages strictly. But bit by bit, more and more like Neos configured things crept in. So the cookie consent, for example, also has to be pre-rendered because like the services is YouTube, Google Analytics, all of these enabled, is also configured in Neos. So we've got a couple of those pre-rendered things. OK, I think I spoke quite fast. This was a lot of things. So let's take a recap. What can you take away for your project, for your performance optimizations? Two things, analysis and optimizations. Analysis. Think of logging as a profiling tool. Don't just dump any information that you somehow need, but think about how can you utilize logging for an analysis goal in the end. Start with making a concept of what fields should I have? When should I log anything? Do I have repetitive events that are triggered on at different points of the code, but should all contextual have the same information? Logging, think of a concept. Second, oh, sorry, never mind. OK, you can. Oh, no, you see a different thing. OK, let's stare at that beautiful rose. I still got my speaker notes. I can continue. Think about, we've got takeaways there. The second thing is Ximer, our hidden profiling gem. Very little overhead, because we do just the data collection on the server and no analysis on the server. And no interruption to activate it with the auto-prepend feature of the PHP ini config. And last, the MariaDB log queries that are not using indices. Turn that logging on, see what happens down in there. That was all the analysis tools. Let's look at the optimization tools. Turn those DB indices on, that's what I said. And think of the benefits that you can get out of a middleware server between you and any upstream API, if you've got an upstream API that you don't control yourself. So observability, deep integration, rendering optimizations, the logging, just in general, the observability and the integration, you can look into what your server is doing. That was a lot, I think. You've got the chance to give me any questions through the NeosCon app, and I'll be around afterwards, so you can just come up to me, and I'll give you more information. There's plenty more that we did there. Thank you.
Thank you. I come bearing gifts. All of our speakers receive gifts. And it's the most fitting for you out of all of the talks because it's a Bienenhotel.
Ooh, Sweden.
And it's tea and honey.
Thank you.
Thank you so much. But before you leave, we do have a question or two.
Sure.
Oh, yeah, we do.
Go ahead.
We do, yeah. The first question is, do you think the process of doing this analysis for a NEOS project can be streamlined and generalized into a guide or package to use for other projects?
I hear like, open source it.
Yes, please.
Okay, yeah, we're working on this. There's a blog post coming up, but you know, we're one of the tech organizers of the conference. There was not enough time to do that upfront. Yes, we are going to open source our analysis tool, for example, of the whole Excimer streamlining, and our thoughts on logging as a concept.
Great. How did you import the products to NEOS, and was this a bidirectional synchronization?
No, this is not a bidirectional synchronization. Every night at, I think, 2 o'clock or 3, we run an import that goes to that upstream service, asks, hey, give me all those products, and then we get all those products, store them locally, and that's why we have a local copy, on the middleware server, a local copy of all the products, and that's why we can do recipes and do like NEOS. Where NEOS shines, the content management, we can do content management on shop content, like deep integration. We can compose recipes out of not NEOS content, out of products that come from somewhere else.
Thank you.
Good.
Do we have time for? We definitely have time for another question. There's so
For
many
another
questions.
question, yeah.
We'll
do
send
have
you the
many
questions and.
Sure, go ahead. I'll be around.
Okay. So, did you consider using event sourcing?
For the basket, actually, we did. I just omitted all of that because I just have a half an hour or something. I don't know what the time it is right now. But yes, the basket is wholly event sourced because there's so many like upstream events, upstream updates, for example. But yeah.
Cool. And one last question.
Sure.
That sounds interesting. Could the Ökokisten cart be used for other e-commerce sites within NEOS?
No.
Okay. That was easy.
No, because
Precise answer.
the complexity is so high, and it's still such a niche solution. So we built this to leverage the power that lies in this system of these ecoboxes. Just for them, the cart is built with like swapping products, because those products, it's not just a stupid swap with any product. It gives you like a one-armed bandit. It gives you recommendations of 3 items from the same group. So it's really like to the last button, it's customized to that shop, to their modern solution.
Wow. Thank you so much, Leonard. Do we have a little round of applause? Or a bigger one? I feel like a big one
Thank you.
is deserved. Thank you, Leonard. Also, please don't forget to rate the talk. Use your little apps that you've already used to submit your questions. Rate the talk. And then, have we updated the time? Can someone wave? Are we sticking to noon, or are we still postponed by 10 minutes? Can someone in der Regie einmal rufen? Irgendwas? Gut, machen wir einfach so weiter. So, let's assume to be back here at 12, or upstairs at 12, a talk here, Strategies for Robust Front-End Architectures with Lisi, and upstairs in the studio stage, we can listen to Carsten, who has already told us earlier in the keynote that he is, what did he call himself, the update guy? Talking about how to update NEOS, or why, when, and how to update NEOS. Thank you so much. Grab a quick coffee, and we'll see you back in 10. Or 20, I don't know.
Hi. Möchtest du? Oh, ich bin noch laut.
Eine Frage stellen, ich würde dir gerade einen Moment geben und sie nicht direkt.
Ja.